Alright, here we're back with average and instantaneous velocities, part 2. Last time all we did was talk about average velocities. Now again, a very common average velocity question is a question that gives you like multiple legs. And you have to figure out an x and a time, and it could have 3 different sections. But you've got to figure out an x, and you could have time for every single part. Now, a lot of problems won't come right out and give you all these x's. A lot of problems will give you like time, and they'll give you a velocity. Well, that's fine. If they give you time and velocity, then you find the x for that part. And the same thing as you go down the list. Find your times, find your velocities. So anyway, our net goal though is for each section is to find out these x's and these t's. So our average velocity for like an entire trip would be our total displacement over our, I can't make the letter T, total amount of time. Anyway, that's what we're looking for. Now, you got to remember to include, if somebody's taking a driving trip and they have a 45-minute break for chicken fingers, you've got to add that 45-minute break. Yeah, there's no x to go with it, but you've got to add that 45 minutes into your total time that's elapsed during the course of this trip. Now, for a neat little drawing. Start out at my house. Draw, yeah, pretty little house. Anyway, there's my house. We'll start out at the house. Oh, almost forgot the front door. And let's see, we're going to kind of go just a little bit uphill. Let's see, there's going to be a 4-way stop. Turn, oh, first we got to turn left. And then there's a 4-way stop. And then I come all the way back over here, and then I stop again. And I turn left, and I come back, and I turn left again. And then the school sets right here. Haha. So essentially, school sits behind my house. Well, not really, but this is basically the turns to get to my house. So, as I said, stop sign, 4-way stop there, stop sign there, stop sign there, school sets right here. Now, this entire distance, for me to make this trip, it's 8 miles. Generally, I make this trip in a time of about 10 minutes. It might be a little more, might be somewhere in there. 10 minutes is a pretty safe estimate for me to make this little trip going here. So if I ask you to find, for my trip, the average velocity or average speed, now obviously average velocity technically looks like it's only about 50 yards. Okay, that's probably not realistic. But anyway, if I ask you to find this average velocity, you might come back though and just say, in general, it's 8 miles over, in this case we got 1/6 of an hour, so 0.17 hours, and you would say my average velocity, 8 divided by that, is, I've got 48 mile per hour average velocity. Realistically, this is more of an average speed though. Now, let's be straight about something. I'm not driving 48 miles per hour the whole way. 48, 48, 48, 48, 48, 48, 48. It's kind of funny, that's actually a road 48. Anyway, 48, 48, 48, 48, 48, 48, 48, 48, 48. Yeah, it's kind of irritating, I know. I'm not driving 48 the entire way. My average velocity, though, is 48. There's a second type of velocity. Instantaneous velocity. Now, when I write instantaneous velocity, I'm just going to write V. Notice, I don't put a line over it. The best example I can give you of instantaneous velocity is this. right here. There's a four-way stop at that location. My velocity right there, it's a 0. Then I speed up as I travel. There's a bridge here. I slow down again. There's a stop sign here. I'll be more realistic. My velocity is usually about 1. Probably a little roll there. This one over here, velocity 0 again. And then 0 again. Coming down through here, some point, I usually don't get too much, maybe 50 miles an hour down through here. In other words, if you look at my velocity at any instant, so in other words, you're not looking at the entire trip, you're looking at any instant. I could be running 65 through here, breaking the speed limit. The state trooper isn't going to care if I try to explain, but sir, if you'll allow me to do the calculation, I can show you my average speed is only 48 miles per hour, and I'm fairly well within my limits. That's not what the trooper is after. A trooper is actually measuring your instantaneous velocity. He's actually doing this. He may not know the equation he's using, but here's what he's doing. Now, the equation for average velocity looked like this. Delta x over delta time. There's your equation for average velocity. Instantaneous velocity. Now, I've already screwed up. Erase that. Instantaneous velocity looks like this. For those of you that had calculus, then this already looks a little familiar. What you're doing in instantaneous velocity, you're taking the limit as delta t approaches 0. In other words, you're not looking at 1/6 of an hour. You're looking for an instant. You're looking for where the time becomes really, really small. We're talking like here maybe 1/800th of a second. How far did you travel in that split second? At that exact moment of time, how far did you travel? The state trooper doesn't care about your entire trip. The state trooper is looking at between two split-second points. How far did you travel between those two split-second points? That's an instantaneous velocity. It's your velocity at any one moment of time. Another way to kind of look at instantaneous velocities, let's take a look at a couple of different graphs here. So let's start off. Two graphs. Draw one here, and we'll make these x versus t graphs like the last video we looked at. Do a second one here. Same thing, x versus t. This one will make a nice linear straight line. Now, when you see a straight line on a position time graph, this object's moving with a constant velocity. This object's moving with a constant velocity. Let's take a look at this object. Now, as you notice the curve, this object is speeding up. This object has an acceleration, so its velocity is changing. Instantaneous velocity is not wanting to know your total x and your total amount of time. Instant velocity is wanting to know what is your velocity at this one single point. How fast are you going right exact moment? That's what instantaneous velocity. Now, we can do that calculation. You make a tangent line to this point, and whatever the slope is of this tangent line, that would be your instantaneous velocity at that moment in time. So at any point, you're going to have a different velocity along there, because this object is speeding up as it travels. That's an instantaneous velocity. So that's your moment at one point in time. So like if you start out in a car, if you start at a four-way stop, your velocity initial, we could say is 0. Your velocity final might be 60 miles an hour. Alright, There you go. There's your difference, though, between initials and whatever. Oh, and what would be your average velocity? That would be easy. Your average velocity, 0 to 60. What's the average of 0 and 60? Take your two velocities, divide by 2. Your average is 30 miles per hour. There's your average velocity. Anyway, thank you very much, and try and see if we can get this video. Thank you.